Okay, good morning, or good day rather, everyone. I believe we're all good. All right, so we have a jam question before us, which says 100 centimeter cube of oxygen is made to react with 50 centimeter cube of hydrogen, and the whole reaction mixture was then passed through anhydrous calcium chloride. So, what is the volume of gas that is left? And we're given this option. Now, if you should come across a problem like this in your jam, this is what you simply do. The first thing is to write an equation for the reaction. The reaction is between oxygen and hydrogen. So the equation of that reaction is going to be hydrogen gas combining with oxygen gas to produce steam, H2O gas. So this is what you have for your equation. Then you balance your equation. So we have two oxygens here. To make this two, we place a 2 here. Now we have 4 hydrogen. To make this 4, I place a 2 here. So after writing your equation, the next thing you're going to write here is, I would write volume ratio. What is volume ratio? According to Gay-Lussac's law, when gases combine, they do so in simple ratios. When gases combine, they do so in simple ratios. They do so in volumes, rather, which bear simple ratios to one another and to the volume of the product. If the products are gases, in this case, the product is a gas. So what that simply means is what? We can say amount, which is mole, is proportional to volume. So this is our mole ratio, 2 to 1 to 2. It's also our volume ratio. So I'm going to say what? This is 2 to 1 to 2. Now, what does this volume ratio tell you? It tells you that whenever you have hydrogen and oxygen combining, the volume of hydrogen that would combine will always be what? Twice of the volume of oxygen. This is 2 and then this is 1. So hydrogen is always twice of the volume of oxygen. Now, the next thing you're going to write here is volume before reaction. Volume before reaction simply means in the question, what was the volume of oxygen and hydrogen that were reacted? So we have 100 centimeter cube of oxygen. So on the side of oxygen, we have 100 centimeter cube combines with 50 centimeter cube of hydrogen. This is 50 centimeter cube. This is before reaction. Before reaction, we don't have any product. So your product is 0 at this stage. Now the next step you write is your reacting volume. Reacting volume. Now, what do we mean by reacting volume? This is what you brought for the reaction, but reacting volume talks about the volume that would actually react according to our volume ratio. Now, for you not to be confused, you simply, this 100 centimeter cube you have here, if you were to bring this down as your reacting volume for oxygen, if I should say this is 100 centimeter cube, remember, according to our ratio here, whatever volume of oxygen that is reacting, we have twice of that volume for hydrogen reacting. So it means here would be 200 centimeter cube. But then we don't have up to 200 centimeter cube before the reaction. So it means this possibility can't occur. This is not possible. So it means the whole of this 100 centimeter cube of oxygen cannot react, because if that happens, we would need 200 centimeter cube for hydrogen. So rather, we're going to have 50 centimeter cube of hydrogen reacting. So hydrogen is called what? The limiting what? Reactant. So if we have 50 centimeter cube of hydrogen reacting, what should be the volume of oxygen that should react? Remember, according to this, The volume of oxygen is always half of the volume of hydrogen. So if I have 50 centimeter cube, it means here I'm going to have 25 centimeter cube of oxygen. So 50 centimeter cube of oxygen would combine with 25 centimeter cube of what? Oxygen. 50 centimeter cube of hydrogen combines with 25 centimeter cube of oxygen. Now, take note that this is 2 and then this is 2. So the volume ratio of hydrogen to steam is 2 to 2. It means if I have 50 centimeter cube here, you also have 50 centimeter cube for your steam. Then lastly, you write volume after reaction. Volume after reaction means we brought 50 centimeter cube for hydrogen, 50 centimeter cube reacted, so therefore no volume of hydrogen would be remaining at the end of the reaction. We brought 100 centimeter cube for oxygen, only 25 centimeter cube reacted, so therefore I have 75 centimeter cube of oxygen left at the end of the reaction. And then at the end of the reaction, we have what? 50 centimeter cube of steam remaining. So when you're done with this, you read your question. The question says what? What is the volume of gas left? What is the volume of gas left? So you can see 75 centimeter cube is in the option. Most students would pick that. 50 centimeter cube of steam is being formed. So how do you get your answer? Now, in this case, they said the whole reaction mixture was passed through calcium chloride. Calcium chloride has the ability to remove moisture from substances. It's a drying agent, or should I say a dehydrating agent. So it means the function of the calcium oxide is to remove the steam from our reaction, our product mixture. So the steam would be removed by the calcium chloride. So therefore, the only volume that would be left at the end of the day is what? Your 75 centimeter cube. So this would be removed by your calcium chloride. So your answer becomes what? You say your volume of gas left, in this case, becomes 75 centimeter cube. So which is option C. Now, supposing this calcium chloride factor wasn't there, your total volume would have been 75 centimeter cube plus 50 centimeter cube. So that would give you what? 100 and what? 25 centimeter cube. But in this case, since the reaction mixture was passed through calcium chloride, the steam would be removed, and then this becomes the final answer. So if the question didn't have this, I've told you, the final answer would be 75 centimeter cube plus what? 50 centimeter cube. I will see you in my next video. Please don't forget to like, share, and subscribe. God bless you.